Welcome back. In this video, we'll discuss section 16.4, approximating the binomial with a normal model. Think back to the example from last time. Let's roll a die 400 times and record the number of ones observed. We'll let x be the number of ones in the 400 rolls of the die. Then we could consider a question like this. What is the probability of rolling exactly 50 ones? Well, as we saw last time, we'd set this up as follows. The probability that x equals 50 is, in this case, 400 choose 50, which ends up being a huge number, times p raised to the power 50 times q raised to the power 400 minus 50. This is a very tedious calculation. And if we consider the question, what is the probability of rolling at least 50 ones, it's even worse, because now we'd have to calculate the probability that x is 50 and add the probability that x is 51 and so on up to the probability that x equals 400. Fortunately, we can approximate the binomial distribution with a normal model. We know the binomial distribution has mean equal to NP, which in this case is 400 times 1/6, or roughly 66.67. And the standard deviation is the square root of NPQ, which ends up being roughly 7.45. Well, it turns out we can use the normal model with the same mean and standard deviation to approximate the binomial distribution. So let's go back to that question. What is the probability that x is greater than or equal to 50? Well, using the normal model, this is equivalent to asking what's the probability that z is greater than or equal to this z-score. So I'm going to use our observation of 50 minus the mean, 66.67, over the standard deviation of 7.45. So we want to know the probability that z is greater than or equal to negative 2.24. And because the z-table reports area to the left, we end up doing 1 minus the value from the table, 0.0125, to get 0.9875. The question is, can we always use a normal model to make estimates of binomial probabilities? The answer is no. We need enough trials, so we need to verify this success-failure condition. A binomial model is approximately normal if we expect at least 10 successes and 10 failures. In other words, we need to check that NP is at least 10 and NQ is at least 10. We'll stop there for now. See you next time.